Welcome and thank you for joining today's webinar with our friend and co-founder and CTO of InGuardians, Beale, in Linux Attack and Defense, exploiting a PHP application and breaking the exploit. It's going to be a good one today, you guys. You are also joined by BeyondTrust product manager Paul Harper, who will run us through an overview and a demo of PowerBroker for Unix Linux after Jay's presentation, so I encourage you to stick around for that portion. My name is Sarah, your webinar host today. A kind reminder to please submit your questions via the chat box in the GoToMeeting console. You should find it on the side of your screen anytime throughout the webinar, and we'll cover your questions at the end during our Q&A time. Also, today's session is being recorded, and all registrants and attendees will receive a link to the recording and the slides shown here today within 1 business day from now. So now that that's all out of the way, I'd like to hand it on over to Jay, who will jump right in. Jay, welcome to the line. I know you have a lot to cover, so please take it away.
Hi, thank you, Sarah. Hi, my name's Jay Beale. I'm going to, this is the second in a series I've done with BeyondTrust, each of these in the series stands on its own. We're going to have a lot of fun today. This series is basically on Linux Attack and Defense, where we take a vulnerable virtual machine and we break into it, and then we turn around and ask ourselves, wait, couldn't I have stopped that attack path? So we're going to have some fun. This is going to be really demo heavy, and we're going to have a blast. I'm going to make sure to give credit where credit is due for the vulnerable virtual machine we're using. So here's my bio. There's my ugly mug on the left side, and so here's what we're going to do. So first, we're going to start out with a Linux system, and this Linux system is a boot to root. Or a one-person capture the flag, and these things are really cool. I started playing with these recently on a vacation because computer security research is what I do on vacation sometimes, and these are a blast. And basically, you can get these things at a site called VulnHub, or if you go to a security conference that has a CTF. Some of their CTFs are team-focused, against other people. Others are things where you proceed as one person and just try to see how well you can do against one system that's been set up like this. And so these capture the flags, or CTFs, are really fun. What I started finding when I was playing with these was, I went through one and I'd get an attack path, and I broke into it and I got root. That's what you're supposed to do on these. You're supposed to go through and capture a flag, or 2 or 3. Some of them have 10 of them. Most have about 3. And so you're as you escalate privileges, you get into this, as you break into the system and then get more access, you tend to get more flags, and your goal is to get to root, and usually that's where your last flag is. But as I played with these, as I played with my first one and then with more after that, I said, wait a second. I teach Linux lockdown. I've been creating tools or writing articles or books or what have you on how to break attacks on Linux-based systems for a very long time, and it so much of this is just best practice. And it turns out that if you use some best practice on these vulnerable VMs, the attack paths I'm taking, they'll work, and that was really fun for me to discover and to play with. And so that's what we're going to do here. So we're going to go through, we're going to attack a Linux system. That's where we're going to spend the bulk of our time, and then I'm going to show you how to defend against the attack with a tool called Mod Security. It's a free tool that's available on Linux distributions, often just by with an apt-get or a yum install. We're going to talk about other proactive security measures you could take to break the attack. The attack we're going to do isn't just going to be one step or one vulnerability. I'm going to urge you as we go through to look for ways that you could break the attack without breaking the app. And that's the big thing we're doing in defensive, in IT security or InfoSec defense, is we're saying, okay, can I make the attacker's life much harder, or can I break what the attacker's doing? Can I break the attack without breaking the app, without making it so that my users are suffering in any way. So the cool thing about this is, if you were to download the virtual machine, the vulnerable virtual machine that we're using, it's called Breach 2 from VulnHub, and you were to download a Kali Linux virtual machine, you could do everything that I'm doing right here, and I urge you to go back and use the recording and do the same thing, and then branch off a little bit. There are other ways. There are a few other ways to root that I haven't used in here, and so while I'm spoiling most of this one for you, I'm not spoiling the whole thing, which means if you've never done one of these, this could be a really nice way for you to have some training wheels. Go and use the video for hints. Try to branch off as you build confidence. Go and find another one. So this attack and defense CTF it's one of a series of 3 that are all themed after the movie Office Space, and a guy named Benjamin Rollin created these. So it's Breach and Breach 2 and Breach 3. So we're using Breach 2, and they're really fun. So if you play with this one, I'd urge you to make your next one Breach, and then after that, Breach 3 is harder and longer. So let's see. So in this virtual machine, we're themed after Office Space. So this is our cast of characters. Obviously, there were more in Office Space, but these are the ones we're going to use. We've got Peter Gibbons, who just really wishes his work was more interesting, and they didn't have 8 bosses, as I recall. We've got Bob Lumberg at the bottom, one of those 8 bosses, and the bane of Peter's existence. And then we've got Milton, who just wishes everybody would leave him alone, and specifically stop stealing his red stapler. As you may recall, Milton in the movie finally gets fed up with having his stapler stolen and being moved to the basement, and burns the office down to the ground. We don't recommend either at InGuardians or I'm sure Beyond Trust taking such drastic measures in the name of InfoSec. But let's have some fun. Okay. So we're going to get to it, and this is where I'm going to go off of the slides until we get to the end and wrap up and talk about what we did. So I really hate demo gods, and so when I'm doing something demo heavy like this, I record the entire thing, and then I edit the video to make it flow easily, and then I show you the video and I talk about what I'm doing as if I'm at the keyboard, and well, I was at the keyboard. I'm just not doing it live in front of you, so you have the minimum number of fat fingering mistypes. So cool. Well, let's have some fun. So I'm going to switch over to our video. So here we are. This is how so many of us on the penetration testing and red team side start our days. We start our day in Kali Linux, and which is just an amazing platform it's an amazing free platform for using attacker tools, having them all ready and organized and well maintained for you. And so we're going to start out with Kali Linux, and what I've done, we've got an IP address for the Breach 2 system, and that's described on the website we downloaded it from. So it's a 192.168.110.151. I'll mention that. You don't have to remember that number. I'll mention that as we're going, and then and we've got 110.110, which is our Kali Linux system, and I'll mention that as we're going. I've placed that first number into my etc hosts file so that we can type Breach 2 most of the time. So the first thing we're going to do is fire up Nmap, telling it not to ping the system first. I'm telling it to do a SYN scan against all the ports, and if it finds anything, to check its version. I'm starting up Nmap, and this is going to be pretty fast. The nice thing about a recorded demo is if there's anything that isn't really fast in here, I've tended to go through and edit it out so that it becomes really fast. So here we go. So our Nmap scan is done. This is the nice thing about having both your systems on the same as virtual machines on the same system. So the Nmap scan is done really fast. We got 3 ports. We've got RPC bind, so that's a port mapper. Might be useful if there's an NFS mount. And we've got RPC stat D, So we might look and see if this thing, if there's NFS exported, but I'm going to promise you we don't find it. And so the other thing we've got is SSH running on the very last port number available. And that just, as an attacker, that just beckons. There's definitely something to be said for putting your SSH server on an unusual port number, and we may come back to that. So, okay, so we found on this vulnerable virtual machine that we've got an SSH server running on this 65,535. Let's try logging into it. So if you log into it the first time, it's going to mention Peter. And so I remember I've skipped past that. And when we try logging in, it says, "Hi, welcome to Initech." And Initech was the name of Peter Gibbons' company. And it says, "Hey, Peter, if that's you, the password is in the source." In the source code. That'll be hard to figure out. Okay, and it says, "Oh, stop checking your blog all day and enjoy your vacation." So ordinarily what would happen now if this was you at home is you'd try a ton of different passwords, and eventually you'd come on using in the source because that's what it says. So all lowercase, no spaces, we just type in the source. And I've spoken through my highlighting, apparently. Okay, so I type in the source, and what happens? I'm waiting, I'm waiting, I'm waiting. Okay. Now, if anybody's spent time waiting for an SSH connection to go through for like forever, there's something you want to change, which is use DNS in your SSH config. Okay, so what happens is we tried logging in. We actually logged in. We actually did successfully log in, and if we wanted to check that, we could use the verbose option. But we successfully logged in, and then we got logged back out. Well, that's a little frustrating. Now we could try a bunch of things, and the first time I did this, I tried just passing commands through and so on. But at the end of the day, nothing really worked here. But the cool thing is, something happens on this virtual machine when you take specific actions, when you're going along the right way. The way they give you flags is they open up another port. And so now if I nmap this system, I'm going to find that I have another port available. So same as before, except that very first port, I've now got a web server. And you're thinking, well, you did promise you're going to hack a web app, Jay, so that does make sense. We should expect a web server. Yeah, totally. So, and almost all of these boot to roots have a web server involved, have a web application involved somewhere early on. It's in some ways that's the way they theme it. Very often, the only thing that the web server doesn't even have to have a vulnerability; it just has to have a password you can figure out. So, here we are. We're looking at Initech Consulting. We've got a hint: beef. It's what's for dinner. That's not from the movie. And it says they really shouldn't have taken my stapler away. So we're pretty sure Milton's going to figure into this somehow. So we could fire up a tool like Dirbuster to look for available URLs, but we did see a blog mentioned as a really clear hint in our when we SSH. So let's go look at /blog. Okay, cool. We find Peter Gibbons' blog here. It sure seems to be running on old software. Let's just back up slightly. It's running on old software. We've got blog PHP, copyright 2006. So as I'm going to tell you, as a penetration tester, I love old software. Anytime I see that software is old, it means things are going to be good for me. In one of these CTFs, it usually means that that's specifically been set up as something for me to have. So at this point, I'm going to go and search. I'm going to go and search for an exploit against blog PHP. And there's a site called ExploitDB, Exploit Database, has tons of these. And the nice thing is Kali Linux actually comes with a local mirror of it and a program called SearchSploit that lets you go and search for exploits. And so the one I find is, I can read these, but the one I end up using here is a persistent cross-site scripting. And this is a really cool thing that this CTF has managed to work in, that there will be other users using the application. So let's go and look at the exploit itself. So anything that shows up in search exploit is in user share exploit DB platforms, and then whatever the path was. So I look at this, and this exploit is not something you just fire off as a web script. It's instead instructions. And it says, hey, the registration link basically has cross-site scripting in the username field, and you can basically put any HTTP tag you want in there. It's about as good as it gets. So the example they use is refreshing the page, to another site. So an attacker might use that for a phishing attack, where they want to send your user from your site to a site that looks just like it to harvest a password. We're going to do something a little bit different. So we're going to take that, and we're going to set up the registration, but we're going to set the registration page to send people to Beef. So Beef, that was our hint. Beef is the browser exploitation framework. And this is pretty cool. If you can get anyone to basically surf to a page that has this hook JavaScript in it, you get a ton of power over their browser, and they generally don't realize it's going on. And that's also pretty scary. Beef can do all kinds of stuff. You can actually port scan somebody's network. Once you hook their browser, you could port scan their internal network over it. That doesn't sound too bad, but you can also start surfing as them with whatever cookies they have, which means if they're logged into their wireless router right now, you're often able to surf over to their wireless router, and sometimes in a very automated fashion, and create backdoors or do darn near anything you want. And attackers out there use this like nobody's business. So what we're going to do is we're going to go and log into Beef. Default password is beef, and username and password is beef. And we've set this up, and of course, anytime something's small, I'm going to zoom it out. And now we're going to go to the registration page. So the deal is the registration page is going to change the list of members on this site, and then we're going to hope that someone that our victim is watching this members site, is watching this members page. So let's go over and register. And just like that exploit said, just like that write-up said from search exploit, all we need to do is put our any HTML tags we want. So in this case, it's going to be some JavaScript into the username field. So we put in that same thing that Beef told us. So script, source, let's use the IP address that we need the hook to be loaded from. So that's our Kali box, 110.110. 3000 is the normal thing, hook.js is the normal thing, and we'll close up this script tag. And so we're going to submit that our username to be displayed on the member page is some JavaScript as a Beef hook. So put in anything we want for a password, any email we want, and click register. Okay, so at this point, what we're waiting for is to see if anybody surfs the page. Now, the cool thing about this CTF, like I said, remember, I get to fast forward for you, but the cool thing about this CTF is that they basically set up Peter's user. On the CTF, there's a browser that's browsing out, and every 4 minutes it goes and looks at the members page. And so here we are. We just saw right over here on this left side, online browsers. We've just hooked a browser, 110.151, and we can go learn about that. So if we click on that, we're going to find, wait, it's running Firefox 15. And my very first thought when I see Firefox 15 is it's a very old browser. Remember how I feel about old software. Old software tends to have vulnerabilities, and so I'm going to go and use a Firefox vulnerability that's in Metasploit. It's an oldie but goodie, and it's very stable. It's rated excellent, and so I'm going to fire up Metasploit, and we're going to exploit this. So right now I've got the browser hooked, and since I've got the browser hooked, I can basically set up an exploit for it to surf to, and I can tell it where to surf, and you're going to see that. So let's go and fire up Metasploit. And Metasploit, I don't know if any of you have been using Metasploit for years. It used to take like 3 minutes to start up, and now it's like 30 seconds. And so many of us are celebrating that. So here's my here's this exploit that's the oldie, but it's one of the oldies but goodies for Firefox. It works all the way up to 1501, and we'll just, I love the tab completion. So in Metasploit, I just use exploit, and I start tabbing through, and I've got to change a few fields. So I'm going to set server host to be where I want the where I want this thing to come to, where I want the browser to be redirected to, and I'll set a URI path for that too. And then I'll also set a place for the exploit to set for the stager to sit. So I'll set server host to 110.110, my Kali system. I'm going to set the port to 80, so it's nice and simple. And I'll set the host that the exploit's listening on to the same thing, and then the URI to slash, and it's this easy. So now I take exploit, and I have an exploit running. Okay, so now I've got this URL, and anybody who surfs to that URL with Firefox 15 is going to find that they're giving me access on their system. And in our case, their system is the CTF, because Peter's logged into it with a browser right now. So we're going to go back over to Beef, and we're going to tell Peter's browser, which we see is still hooked in the upper left corner, that we want it to go to our exploit. So I'm going to search for redirect. There are a few different redirects. I can start up an iframe and redirect there, or I can just redirect the whole page. And I just put in our URL where I want it to go. And God, Beef makes it. Beef's a really mature tool. It's been around for a while, and I definitely urge you, if nothing else, play with it, because you'll be shocked at what a browser can do. So we've set this up. We've told Peter's browser where to go, and Peter's browser immediately surfed over to Metasploit, and Metasploit started telling us, okay, hey, I'm seeing this. And at this point, I fast-forwarded a bunch. I had to wait a while to get my session, and now I've got my session. And my session means that the browser has connected to the exploit, and I've gotten code execution. So in Metasploit, I use sessions to see all the different machines I've owned and to interact with them. It's not uncommon on a pen test to have a ton of machines that you've all got connected in as sessions. So I type ID and I say, okay, so I'm Peter, and I see what groups Peter is in. He's in that fisherman group, and so I'll say that when I did this, I investigated it. But what I'd like to know first is, why is Peter's system, why am I getting logged out? When I log in as Peter, why am I getting logged out immediately? And so there are two places I can imagine for that. The one is either something's weird in SSHD config, or the other is something's weird in his bash RC or his profile in his shells file. So I find my culprit in SSHD config. It says that it makes everyone run start me, and start me must be what's logging me out. So here's what I'm going to do. I'm going to avoid getting to the point where I'm forced into that command by replacing Peter's bash RC with an exec. Exec basically says, stop whatever you were doing, start this other program, and you're gone. Execution is now this other program. So we're just going to start a shell that won't read that file. And so once I do that, I should have, at this point, unbroken Peter's login. Now you might say, wait, you've got a shell as Peter through Metasploit. Why are you going to go and do something else? And I'm going to tell you, I'm doing something else because that shells you get out of exploits are often short-lived, and so you've got to find a way to get persistence as quickly as you can. So I'm going to log in. I'm going to log in now as Peter into that system. I'm going to type the same password I did before in the source, and now I've got a real shell. Now I've got something stable. It's as stable as SSHD, which tends to be pretty stable. So I'll look at what other users might be on the system. I see Bill and Milton and Peter. Remember, that was my cast of characters from before. I'm going to take a look at their home directories. and I don't see anything interesting to start. That Firefox SH is the script that's getting Firefox to run automatically. Let me look around the system a little bit more. I'll look in user local bin and user local sbin, see if there's anything custom to this environment I might be able to use against it. And I see one thing, cd.py, and if I look at cd.py, it's a Python script. It's a really simple one. It just asks the user whose stapler it is. And if you answer mine, it goes forward, and if you don't answer mine, it exits. Okay. I'm going to look for setuid programs, because this is one of the big ways I escalate privilege, is I see if there are any unusual setuid programs. Okay, I don't see any unusual ones, and I don't see any kind of unusual permissions on them. Okay, so at this point, let me just see what ports are listening on this system, because I might have things that are available locally that aren't available from the network. Oh, there's one, 2323. It sounds a lot like a Telnet server. Telnet's 23, but so people tend to, if they make another one, they make 2323. I could try to nmap to find out, but there's no nmap on this box. So let me try just telnetting into it. Okay, so I telnet into it, and I get a set of coordinates. I get a set of GPS coordinates. So when I throw those GPS coordinates into Google, I get that it's somewhere in Houston, Texas. Oh, okay, well, yeah, Houston sounds like a good city, but I'm pretty sure it's going to be a password hint. So let's try it again. What user should I try now? Well, I tried Peter already. I've got Peter, so I've either got Bill or I've got Milton, it seems. So let's try Milton. And I can try a bunch of different passwords, and let's assume I did, but eventually I land on Houston with a capital H. What those credentials, what those coordinates came out to. And oh wow, this thing's running our cd.py. Whose stapler is it? I type mine, and now I'm Milton. Okay, I've got my second user. This one doesn't give a flag here, but this is ordinarily where one of these CTFs would give you another flag. Okay, so I'm in Milton's home directory. Let's kind of look around, and let's do another netstat. Oh, cool! Look, we've got a whole nother listening service that opened up as soon as we logged in as Milton. Now we could go and explore and try to figure out how that happens and see if there's a vulnerability in how it spun up a service, because a user logging in, spinning up a service usually means that user had no privilege. And I did that a bit, but we're going to skip that here, and we'll just skip to the things that worked. You're going to find that a lot of hacking, it's when you're watching a demo like this, it's really, really fast, but in real life, there's at least 4 or 8 times as much trying stuff that doesn't work before you find all the things that do. So let's go and start up a browser in our Kali system, and let's go to that weird port, 8888, that is now newly open. Okay, we find OS Commerce and an index.html. And OS Commerce has been rebranded a little bit for this work. There's now a pro PHP security book sitting here, which I'm very happy to see. And it's also similar to the movie. It's the Flair store. Welcome to the store where you can buy all kinds of flair. So OS Commerce is we can look up for vulnerabilities, and I will tell you that if you do this at home, you'll find that there's some vulnerabilities in OS Commerce that you could use. You don't actually need to, but I think that if you want to go back and repeat this at home, you should stop at this point and try to use vulnerabilities to get what we just got, what we're about to get, which is, turns out OS Commerce's default credentials, admin, work. Oh gosh, okay, well what do we do with that? Our very next step, whenever we get into any kind of PHP-based app, if we're able to log into it as some kind of administrative role, is see if we can add a new PHP file to the site. God, that's got to be one of the biggest weaknesses in some of these apps, that they just let you add. They're written in a language, they let you add more files in that language willy-nilly. But I guess if you're why would we do that? Well, we're trying to turn admin on the application into shell access as whatever the application's running as. So first thing I do is look at templates. That's where WordPress would have given me some ability to to add PHP files. Nothing in there. Okay, cool. Well, let's File Manager. Let's look at File Manager. Okay, File Manager would be nice. There's an upload link. So now I just got to find a place that I can upload. All this stuff is permissioned well. It's all owned by root and not writable by anybody else. So I'm going to hunt around, and I could go and look in backups. That would be kind of nice to find, credentials or whatever in backups or other useful data. I can look at includes. I'm not finding anything there that's writable. I'm looking for something that's writable by my user. I just need one permissions problem, and that will get me in. So I look at another includes directory, and look at that. I find a work folder that is writable by all the users, including mine, which means I can go there and I can upload something. So what am I going to upload? Well, as I did in my last, in the last Beyond Trust attack and defense demo that I did here, we found that there was a PHP reverse shell in Kali Linux. There are a ton of web shells. And so rather than show you where that is in Kali Linux this time, I'll tell you the file name, but I put one in my home directory. And to speed things up, I've edited it already and given it my IP address. So let's look at this reverse shell. Pentest Monkey made it 10 years ago. Oldie but goodie. Everybody uses it. And I find there are only two things I have to change, the IP address and the port. I'm going to leave the port where it is, and I've changed the IP to the Kali Linux machine just for speed. So now I set up a netcat listener to catch the reverse shell. So I'll listen on 1, 2, 3, 4. And now I just upload this PHP reverse shell that I've pre-configured. I upload it, and now I'm going to find that it's in work. So what I need to do is go to that URL so that the PHP interpreter will run that code. So I've got a OS Commerce, and then I've got includes work and the PHP reverse shell. Okay, it says connecting and nothing seems to be happening, but look, over here, our netcat listener, it's got a shell. So I'm now running as our third user, who we thought was Bill from the name of his home directory, but in a very unusual way, that user is actually B. Lumberg, for Bill Lumberg, the guy who's stealing Milton's stapler, making Peter Gibbons' life a living hell. So let's see what Bill can do. Sudo -L is a really useful command on these CTFs. You'll find people use it all the time. Actually, the part that we're about to do right now is something that one of our folks, Adam Crompton, did this week. I watched him do it this week on a penetration test against a much, much bigger Linux server than this one was, where he ran sudo -L, and he found that the admin had specific commands he could run, and he was able to find a way to turn one of those commands into every command. So we find that Lumberg can run TCP dump. And the cool thing about TCP dump is it will take an argument that is a command to rotate the packet capture logs. And so all we got to do is make a command for TCP dump to run. So let's switch over to our Milton shell for a second. And let's create a command in Milton's home directory. So the nice thing about Milton is we have a really straightforward shell here, and that's the last place we got to. So I'm just going to write a get shell, and get shell is just going to be what we want TCP dump to run. And so I'm going to write a quick bash script, and this bash script is going to change the sudoers file. So here we go. It's going to add one line to the sudoers file that says Milton can run any command as root that he wants, and he doesn't need to enter a password. And that's all this thing is. So it's going to append that to the end of the sudoers file. If I was living dangerously, I could replace the sudoers file with that, but, well, that wouldn't work because then I'd miss the thing I would need it to use. But I could replace the sudoers file entirely so that it would give Lumberg a chance to do this, and it would give Milton everything. Yeah. I guess it would work. Huh. Cool. So here we are. We've got we're back on Lumberg's terminal. This isn't a real terminal. I could make it one with a Python import spawn the way we did in the last boot to root on Beyond Trust. but instead we're just going to type our command. So here we go. We're going to fire up TCP dump. We're going to tell it to listen on ETH0. We're going to tell it where to write packet capture files and to cycle those files every 1 second. And we're going to tell it to run get shell, the temp get shell to cycle. And so that will run TCP dump as root, and TCP dump will run temp get shell as root. And so the way we can figure out whether that worked is go over to Milton's shell and try typing sudo. And here we are, we're root. Freaking awesome. Pardon my language. So I look around the root's home directory and I see my flag program. So let's run that. Okay, here's our congratulations flag. So this is cool. So that's the attack path. And now what I want to do is show you how to break it with mod security. So mod security is an Apache module, or was created as an Apache module. It's now available for Nginx as well. It is basically a web application firewall that you can put on an Apache or Nginx server, and it's an open source project. So you could put it on every single web app you have, or just one web app. You don't have to get this thing and put it inline on your network. You don't have to get permission and buy-in and talk about whether that's going to slow things down or what have you. You can try it one server at a time, and it's free. I teach this in my classes, and so I'm giving you a piece of that right now. So we're going to set up mod security, and the first thing I've done is I've already done this. If apt-get installed mod security straight out of, this is a Debian system, so straight out of Debian's package repositories. And you'll find that you can go to GitHub to get it, but that's kind of the easiest way. And now I've got to configure it. So I'm going to configure mod security. It comes by default set to just detect only, and we're going to tell it to be on. So sec rule engine on. These things basically just go straight into your Apache config file, but it's broken out around the file system to make it easier to manage. So I'm going to go to the Apache mods enabled, there are tons of Apache modules that do different things. To enable them, you basically symlink their config files into mods enabled and put a load statement in there as well. And so we're going to go to the mods enabled, and we're going to add a couple lines. I've done all of this to make the typing easier just by adding the lines ahead of time and uncommenting them out for you here. So we've got these lines that basically say, hey, go look at the mod security core rule set, mod security CRS. That's the thing that's maintained as a separate open source project, and that's the thing that's getting updated with all the rules that say this is bad traffic, and use all the activated rules. So there are a lot more rules, and we're only going to activate some of them. And you activate rules by symlinking them into the activated rules directory. So now we're going to go over to where all the rules are kept to user share mod security CRS. This is the thing that you sync from GitHub basically. And I'm going to go into activated rules, and if I look at the README, it says, hey, symlink things from the other rules directories. So let's look at base rules. We're going to basically take everything in base rules, and we're going to symlink it into the activated rules directory. Now, you should do this as one step, but I did it as two. So I did this so I just create a quick for loop on the command line. It says, hey, take everything that ends in .conf and symlink it into activated rules. I should have just basically done that for everything, for not just .conf, but also .data. So these rules are turned on, but they've got data files that they need too. And so my next segment is basically doing the same thing for the .data files. Oh, we have one more thing we have to do, which is mod security's default is that if traffic matches on any rule, it's going to get blocked. And unfortunately, that ends up having some false positives here and there. In the case of our demo, it would have false positive on us hitting the web server as an IP address instead of a host name. So instead, we can use the most powerful part of mod security, which makes it so that it doesn't have much of a false positive rate at all, and that is, we say, instead of having the traffic blocked by any one matching rule, it's going to instead, we change the sec default action, it's instead going to be passed, but that rule gets to, that rule that would block it basically gets to contribute to a score. and to an anomaly score. And then we're going to change the way this thing works into an anomaly scoring method. And so the last part to do that is basically just to activate this rule. And this rule basically just says, hey, let's turn on the anomaly method. And you can tune this and configure this for better false positive detection and whatnot. But we're not going to do that right now. So we're going to restart Apache. And we have this, we tried restarting Apache, but Apache wasn't on, so we have to start it from scratch on this at this stage. So the other thing, though, as I said, was that I missed the data files. And so we're going to go back into, look at the base rules. We see all those data files, and we're going to look at all those data files and symlink them in too. So normally we just do this in one step, one for loop instead of two, but so be it. So we've got mod security set up now, and so let's try our same attack. So remember, the first stage of our attack on Peter's blog was to go and put in our persistent cross-site scripting into username. So we're going to try to register that username. And I'm trying a slightly different one. And this is badactor@example.com. And I'm going to find that when I try to submit that, I get a forbidden. And this is how mod security blocks things. So if you've seen a WAF block things like this, it's often got mod security in the back end. Let's make sure we didn't break it for our normal users. I'll just register as a normal user, no attack present. And hey, I'm allowed to register. So that's mod security doing its job. So what I want to do at this point is switch back to our slides. And I'm going to be turning it over to Beyond Trust in just a couple minutes. So I'm going to tell you one other thing you can do with mod security, and that is that you can, what we're doing here is using all the built-in rules. And those built-in rules have a ton of these rules. If you look at them, they're all basically regular expressions or string-based pattern matching, and they're matching things that are known to be bad. So they've got 8,000 different ways, I'm making that number up, but a ton of different ways for catching SQL injection and cross-site scripting. And that's called the blacklist approach. And it's very popular because someone else can maintain your blacklist and you don't have to do much work. It tends to block almost everything. If you wanted something that was even tighter, like you had a really, really vital web application and you wanted to make a really, really tight rule around it, or there was a vulnerability in that application and there wasn't a patch for it and you needed to basically, and it was getting past the WAF, past mod security, you could create a rule that basically said, okay, for that vulnerable input form, we're going to look at the parameters, ideally the vulnerable, maybe just the vulnerable parameter, maybe all of them, and we're going to basically create a rule. And the rule will be, hey, if parameter 3 on the GET request doesn't match this regular expression, which basically says alphanumeric 1 to 15 characters, nothing else, no symbols, no less than, greater than, etc. If it doesn't match that, then we deny it, then we block it. So that's the other thing you can do with mod security. In classes I teach, we do a bunch with that, and then we also use the core rule set. You'll find the core rule set is really, really powerful, and most people don't need to go anywhere beyond that. And I'll tell you, there are great books on mod security. It's a really, really powerful tool. So let's just go over our attack, what happened. So we started out, we port scanned with Nmap to find our SSH server on the last port available. We guessed Peter Gibbons' password. We port scanned again, we found Peter's blog. We used persistent cross-site scripting to attack Peter. We hooked his browser with Beef, the browser exploitation framework, and then we exploited his browser with Metasploit. We looked around a little bit. We found a telnet daemon, so we went into that, and we got a new user and a new application, the OS Commerce. We guessed the password on that. We planted the PHP web shell. Hint, that's the place where there were some other exploits you could try that would work. We got a privileged user, Lumberg. We found Lumberg's sudo rights let him run TCP dump as root. And so we created a packet capture rotation script to modify the sudoers file on the system. And then we ran TCP dump. We got sudoers file. And now we gave Milton sudoers so he could burn down the building like in the movie. No, we used Milton's new rights to run sudo su, get root, get the flag. So how did we do it? What was our defense? Our defense was we used the open source mod security tool to protect, and we can use that to protect any application that runs through either Apache or Nginx. So we could also break the attack at a few other points. One was like in some of my blog posts, you could use OSSEC to create a firewall rule that blocks the attacker as soon as the first port scan fires. You could use a firewall rule set to stop these servers that were giving us reverse shells from connecting outbound in the first place. You could prevent the web applications from accepting new code uploads. That would be something I'd do via AppArmor. I could also do that with file permissions, but AppArmor would be even stronger. And then the last one is I could restrict the sudo rights so that tcpdump couldn't give away root privilege. Like I said earlier this week, one of my coworkers, Adam Crompton, used something like this. It wasn't tcpdump, but it was another thing where the admin was allowed to sudo, and what they were allowed to sudo was a little too broad. Maybe we should have let them sudo a script instead of sudoing the command, which might have an unknown flag. So that's the other one I really like if I'm an attacker to audit anything that lets a user move up to root. As a defender, that's also what I want to be looking at. So last part before I hand it over, you can find more of my blog posts on InGuardians site under labs. You can also find them here at Beyond. You can also find other ones here at Beyond Trust. And then you can find the Breach2 VM and lots of other ones at VulnHub. You know where to download Kali and mod security on GitHub. So also, I'd love to see you in one of my trainings or talks on Linux security. Thanks a lot. I want to hand it over now to Paul.
All right. Thanks very much, Jay. That's a fantastic demo. I think you are the only person I co-present with that does more command line stuff than me. So that's great. It always makes me feel good. Just to wrap up today's session, I'm not going to spend too much time going overly technical on things. I'm just going to talk a little bit about some of the things we do here at Beyond Trust that really help mitigate the chances of a breach occurring. Just to get things rolling, I'll talk very high level about some of the things that we do here at Beyond Trust. So one thing that's hopefully clear from Jay's excellent demo is that there isn't like a magic command that suddenly just lets you compromise a box. You don't just run go to one web page and click on a link or run one command and suddenly end up with a root level shell. There's a whole slew of steps that you go through. Sometimes your life's easier if you're running older software, or if you sometimes you just get lucky, particularly when it comes to things like guessing a password. But you do need to go through a number of steps, and security is much the same thing. There's not a magic application you just install that gives you complete defense against any attack. So at Beyond Trust we have a number of things that help mitigate the chances of you being or having a host that becomes compromised. So again, I'm not going to go through everything here that's on the list, but things that will actually relate to what Jay showed would be things like an AD bridge, for example. Tie your accounts back to Active Directory, you end up with stronger passwords that change on a frequent basis and stops people putting up like a message of the day, including their password, that sort of stuff. Vulnerability management, scanning for old, out of date, or software with known vulnerabilities, and making sure that you're patching stuff obviously is a good thing to do. The area that I focus on, though, which is really again relevant to what we're looking at today, is in that privilege management space, whereby we deal with things like making sure that when people are on a box that they only have the required level of privileges, and things like again tying this back to Jay's demo. If you have a local sudo as file, or you're managing privileges there on that box, that's risky. That's one of the first targets in terms of trying to get elevated privileges. So we help with we help with dealing with the way in which privileges are managed on a particular host. So as we're looking in the Unix Linux world, again, I'm directly responsible for our PowerBroker for Unix and Linux solution. We also actually do have a PowerBroker for sudo solution as well, so we can help improve security in and around sudo, or if you want to go to our our full least privilege solution, does the same thing, only it's got more safeguards, more flexibility. And the goal of PowerBroker for Unix and Linux is to, again, eliminate the sharing of those privileged credentials, so people don't have passwords that become static or old, easy to guess passwords, that sort of stuff. Track and audit all of that activity. That's again really important for forensics. System level control is actually a really important one, because that allows you to do things like run TCP dump, but stop it from spawning privileged shells, as Jay used in his example. But more importantly than that, things like allow scripts to run, but make sure that scripts don't contain compromising I guess commands, things that rebooting systems, or add in unauthorized privileges, that sort of stuff. And also PowerBroker for Unix and Linux, despite the name, actually does extend beyond just Unix and Linux platforms. It's really anything that you can SSH to. So there are obviously compromises or controls that you want to put in place for other things like routers, switches, firewalls, access points, that sort of stuff. So the big difference, and again, I won't spend a lot of time, breaking down the whole architecture. The main thing is the client, effectively, where Jay was initiating all of his work, or even the systems that he was trying to breach, so like the breach 2 system, had a local sudo file. If you go with a Beyond Trust solution to improve security, one of the first things we do is we offload all of that audit information and all of the policy information, effectively like the sudo file, onto dedicated servers. So those servers, basically, there's no way then of creating a malicious sudo file, because it doesn't actually exist on that box. Again, we audit all of that information off on separate machines, and really the goal here isn't to bring security that isn't obtainable. It's just to make security easier to obtain and easier to manage. So again, just a few other things, auditing activities that occur inside scripts, or stopping, certain binaries from spawning, additional, elevated privilege type stuff. You can even allow somebody a root level shell, but still control what that root user can do. So you can lock down, file and folder access, for example, even for root. And then basically blocking malicious or tampered binary, so checking a binary ahead of time. That includes things like file integrity monitoring, so you can make sure, again, some of the things that that Jay did during his demo was he was changing files. He was updating like one of the bash profiles for one of the users. He added a file that a PHP file which he could then call from a browser in order to implement an exploit. Obviously, changing the sudo file was another thing that he did. So monitoring for file changes is another really important part of security, which is again is something that we do or we include with our least privilege tool. And again, I talked about, we just basically make implementing all of that security and auditing stuff that's going on those boxes just easier to do. So, generating reports, have reports automatically generated, give you that big view of what's going on in your environment, because obviously you can't be looking at every box on an individual basis. So we actually scoop up all of that information, centralize it, centralize your policy, audit, control or change control around those policies, and all of that audit data to see where things may potentially be happening that are not really desirable. So I've got a slide here that says product demo, and I'm not going to just because there's not the time to go through all of the things that we can do in the product. I would literally be talking for hours to even touch the surface on some of this. But just to give you a non-command line view of some of the stuff that we can do, I'm just going to go ahead and log into our web console, just so you can see how we can do some very simple stuff here to again help improve security. So first thing is, I can go off, discover all of my hosts. I've got a number of our privilege tools set up in this console. You don't have to see them all, but our AD Bridge, our least privilege tool, PowerBroker for Unix and Linux, as well as the PowerBroker for sudo solution, which again centralizes that sudo file and puts a number of controls around it. So it's very easy here to come discover your hosts, and then you can do things like if you wanted to deploy our sudo client, it's as simply as choosing the install option, and then you choose which server basically you want to use, or servers you want to use for that centralized policy. and then obviously some credentials to actually go out and do the install, including delegation like pbrun sudo su to actually get the client software actually in place. Once we've done that that deployment and we have all of our components in place, and obviously as part of the discovery we will check that those machines are ready, do the deployment for you, we can do upgrades, that sort of stuff. The key thing I really wanted to get to is some of the management now can all be done from a web interface. So for example, as we were talking a little bit about sudo today, I'm just going to go ahead and look at one of my my sudo servers. On here I can basically manage my sudoers file, I can make changes to it. When I make changes I get version control. If I do make a change to this file, we'll just put a comment field in there. I can do change management, so for somebody to actually justify the changes. We got a full web-based editor, so we can check the syntax, make sure that any changes I make, are good. But again, change it one place centrally, and then that can be consumed by one or more hosts. But not just with the sudo stuff. We obviously implement our own policy controls. So I can do role-based policies. So I just pick one here. Let's do this scanner one. So real simple, just who, what, where, and when. So I can choose users that can submit commands, run users, what commands are allowed to run there, or just like grouped together. So all commands, basic commands. But again, making that privilege stuff much easier. So you're not going to expose yourself like you could potentially do with a sudoers file that isn't tightly locked down. We can bring that all up to a nice graphical level. And the last thing I'll touch on here real quickly is file integrity monitoring, which I've actually got on a different server. And our FIM policies, again, that's built directly into to our least privilege tool. So if we were to go and look at, say, like my lab demo, I got a couple of policies here, looking for changes to files or log in what happens inside scripts, that sort of stuff. I can look at my file changes. It says what my target is. It could be files. Obviously, it could be directories, devices, symlinks, that sort of stuff. But in here, very simple to see, hey, I want to know if the file or folder size changes, if the hash on the file changes, if somebody's changing permissions, does the UID change, if the GID changes, that sort of stuff, date and timestamps. So you choose what sort of things you want to monitor. So you build up these policy definitions. Once you know the sort of stuff you want to monitor, it's as simple as saying, hey, this is actually what I want to look at. So I want to look to see, is my etsy group file being modified? Is the etsy password file being modified? This one would obviously be very relevant for Jay's demo. If something changes in the sudoers file, I want to know about it. And then again, those reports can run as often as you like. They'll get centralized. You can generate alerts, and then go and see why are these files being tampered with. Obviously, if you centralize your sudoers file, monitoring it on each host becomes a moot point. But you can see how easy it is to specify folders or files, monitor subfolders, follow symlinks, follow off device, that sort of stuff. And I know that gets us right to the top of the hour, so I'm going to actually drop back to our slideshow. I think we have one more poll to wrap things up, so I'll pass it back to Sarah.
Thank you so much, Paul. Appreciate it. So I know that was a really fast demo, everybody, but if you'd like to be contacted for a more thorough one-on-one demo of PowerBroker for Unix, Linux, or any of our other PowerBroker products, or even Retina, select yes, and somebody will reach out to you and schedule that demo or that deeper conversation about our products and our solutions. So yeah, jump in there, say yes. We'd love to chat with you about privileged access management. So go ahead, select one of those options, and let's jump right in to just a couple of questions. Jay, I had this come in for you. So where could someone get one of these capture the flag machines to play with?
Sure. You can go to, so the very best place to go is to vulnhub, vulnhub.com, and you can download these things. You can even download them with walkthroughs by people who have done them before, or you can do a fresh one. If it's never gotten a walkthrough, then you can be the first. It's kind of like being a rock climber and saying first ascent. If you're the first person to publish a walkthrough, it's kind of like you're the first one who solved it, and that's really cool.
Jay, you mentioned using. Oh, go ahead. Yeah. What's that?
Yeah. I just wanted to say, like, if you're out there and you're thinking about a demo, make them show you the. If you're thinking about getting a PowerBroker for Linux demo, make them show you the screen recording, in essence, of how you can record, how you can replay an attacker's keystrokes. Oh wait, I mean an admin's keystrokes, but I think of every user, even the admins, as attackers, because it's pretty cool, especially if you have an attack that's ongoing right now. Okay, what's the other question? What's the next question?
No problem. Thanks for that, Jay. So you mentioned using firewall rules to block servers from connecting outbound. But how do you manage that when the servers need to patch and install software?
Oh, sure. So, yeah, I mean, an egress firewall rule set. That was something I kind of threw out there on our last slide. And an egress firewall rule set will make it so those reverse shells don't get back to the attacker. And those are just really, really powerful. They're slightly inconvenient because when you do need to patch a server, or you do need to install software, you got two options. One is you centralize that so that all the software and so that all the patches and installations come through one of your other systems, and lots of enterprise shops do that. If you're not ready for that, and I've seen that done all kinds of places. We did that at InGuardians with our servers. But the other thing you could do is just remove the firewall rule set blocking it. If you make those egress rules local to the system, someone can't change them until they've gotten to root anyway, and they're usually trying to get to root. So you could make them just local to the system, which makes them really easy to drop, patch, and then put right back in place. Obviously, you can, if you could figure out where they're patching from, you can make the rules more specific. But yeah, that's what works.
Okay, guys, it is past the top of the hour. I want to be cognizant of everybody's time. A reminder that you will also receive an email with a link to the recording and the slides shown here today. It will come from communications@beyondtrust.com, so make sure that email alias is whitelisted so you receive all of these assets and the follow-up without any interruption. And a huge thanks again to Jay and Paul. Fantastic job today, you guys. We love working with you, and we love the attendees asking their questions, engaging with us. And thanks for all the demos, Jay. Pretty wild. So we had a lot of fun with you, and we will see you at our next one. We appreciate you all, and have a great rest of your day. Take care, everybody. Goodbye.